Okay, so I'm just creating this video in case that we have any problem with technology today. If that's the case, I'm gonna post this video on the school website. You're gonna be able to get the information from there. And during the last class, you were learning how to calculate the amount of grams that you have in a mole of a given element. And you know that to find the molar mass of a given element, you go to the periodic table and the molar mass is going to be equal to the atomic mass expressed in grams. You already know that. So, miramos, that's okay. So if we want to convert 3 moles of iron into grams, we know how to do that using the periodic table. But what's going to happen, miramos, if we need to measure 3 moles of iron oxide. Iron oxide is a compound. How are we going to convert the mole of the compounds into grams? Using the molar mass too. Oh, how are you going to find the molar mass of a compound? That's today's objective. You're going to learn how to find the molar mass of compounds, and then we are going to continue using that molar mass as a conversion factor when we are doing or when we are solving conversions. Okay. And here you have 2 examples, super easy. 2 examples of how to calculate the mass or the molar mass of compounds. See, you have an ionic compound over here, sodium hydroxide. How are you going to find the molar mass or the mass of 1 mole of sodium hydroxide? Super easy. You're going to multiply the atoms of each element that are present in that compound by the molar mass of the element. Where is this information coming from? The periodic table. So in sodium hydroxide, you have 1 atom of sodium, 1 of oxygen, 1 of hydrogen. See? 1 of each one that are multiplied by the molar mass of every element involved in the compound. When you multiply that, you add all the numbers. So in other words, the molar mass of a compound is going to be equal to the sum of the multiplication of the number of atoms of each element involved in the compound times the molar mass of that element. And over here, you have the answer. In 1 mole of sodium hydroxide, this is the amount almost or around 40 grams of sodium hydroxide. Just keep in mind that it's very important to work with the correct amount of significant figure. That's why I didn't round this to the nearest whole number. Another example over here, see, you have 1 atom of carbon, but you have 4 of chlorine. And that's why you're going to multiply the atomic mass of chlorine expressed in gram, molar mass of chlorine times 4, the molar mass of carbon by 1. When you add that, the sum of that multiplication is going to give you the molar mass of carbon tetrachloride. In 1 mole of carbon tetrachloride, you have 189.856 grams. Okay, if you want to know what is the mass that you're going to have in 2 moles, the only thing that you have to do is just to multiply by 2. Or if you want to know what is the amount of grams that you're going to have in half of the mole of carbon tetrachloride, you can divide by 2. But remember that you're going to do all that analysis when you are setting up your conversion factor. Okay, here we have an example of a problem in which you have to use molar mass. They are giving you extra information about sulfuric acid, and they want to find the mass of 3.5 moles of sulfuric acid. If we are going to start with the first step, 3.5 moles. Remember that sulfuric acid is an ionic compound because it's an acid. So representative particle in sulfuric acid formula units. Later you will know why you need this. Okay, what are the conversion factors that you have in there? Okay, first you're going to analyze. I have moles and I need to go back to grams. Mole grams or grams to mole. This is the analysis that you have to make. Mole grams, grams to mole. Depending on the given, you know that you have to use the molar mass as a conversion factor. Molar mass of sulfuric acid. is the sum, the sum of the multiplication of the number of atoms of each element involved times the molar mass of each compound. Once that you have that, you can establish your conversion factor. In 1 mole of sulfuric acid, you have this amount of grams, and that's the molar mass of sulfuric acid. Now, next step is to setting that up. You're going to start with what you have. You have 3.25 moles of sulfuric acid. And always you're going to multiply by a conversion factor. But you have to set that properly. If you have over here moles and you want to get rid of them, the moles in your conversion factor, the mole goes into the denominator so they can cancel. So in 1 mole, you have this amount of grams. And remember that you're going to treat this as a fraction. You're going to multiply numerator by numerator, denominator by denominator, and then you divide. In this case, you don't need to worry about that because you have a denominator here, 1, 1. So when you divide a number by 1, identity property is going to be equal to the same number. This is the answer. But if you look at your problem, you have only 3 significant figures. So you have to write the final answer with only 3 significant figures. Okay, so you use scientific notation, 1, 2 to the left, meaning that in my power of 10, I have to add 2. And that's what I did over here. Round to the number because I need only 3 significant figures. That's the answer for your problem. Okay. Now, this problem, okay, is a little bit more complicated, and you can see that in the amount of calculation that I'm showing over here. Because they are giving you, let me see, they are giving you here a sample of carbon dioxide. And we're going to start with the first step. Carbon dioxide is a covalent compound. Covalent compound, what are the representative particles? Molecules. Okay, so you have over here a sample of 52 grams of carbon dioxide. Conversion factors that you know. Okay, in 1 mole of carbon dioxide, you have Avogadro's number, molecules of carbon dioxide. See? You know that. Okay, in 1 mole of carbon dioxide, see, that's the formula, you have 1 mole of carbon. In 1 mole of carbon dioxide, you have 2 mole of oxygen. And in 1 mole of carbon dioxide, how many grams you have is not a given. Can you look for that? Yes, because that's the molar mass of carbon dioxide, and you already know how to find the molar mass of carbon dioxide. You have the molar mass here of carbon dioxide. So in 1 mole of carbon dioxide, you have molar mass of carbon dioxide. Now, with all those conversion factors, how you find the amount of carbon atoms that are present? Okay, my third step is to set up, okay, conversion factor. Yeah, I'm going to start with what I have. I'm going to start with what I have. Super important. I have 52 grams of carbon dioxide, but I want to get rid of the gram of carbon dioxide because I want atoms, okay, but I have grams. So I'm going from grams all the way to moles. Grams of the way, because in order to get rid of, I'm not thinking about the final answer, I'm thinking about what I have. If I want to get rid of the grams, I need to, in my first conversion factor, somehow I need to have grams in my denominator. And what is the only conversion factor that is related, that has grams involved? Molar mass. So I'm going to start with my molar mass. Grams in the denominator, so in 1 mole of carbon dioxide, I have my molar mass. Okay, so when I cancel the grams, I am left with mole of carbon dioxide, but I don't want that. I want an atom of carbon. In 1 mole of carbon dioxide, how many mole of carbon do I have? I have 1, okay, because you can see that from the formula. So I'm going to cancel mole of carbon dioxide, and I'm left with 1 mole of carbon, but I don't want mole of carbon. I want atom of carbon. So in 1 atom of carbon, I have Avogadro's number, atom of carbon. See that? Okay, when you were doing your dimensional analysis, you were getting rid of the units that you didn't want until you were getting the one that you want there at the end. That's why dimensional analysis is super important in problems like this. Miramos how I'm gonna solve this chorizo. You know that, okay? See, the same way that you were multiplying fraction, numerator times numerator, denominators times denominators, and then you divide. You have the calculation here. I was multiplying all the denominators. Do not forget about your power of 10. I have that over there. I was multiplying all the denominator, putting that over there, and then I was dividing. And you have to express that with the correct amount of significant figures. 7.11 times 10 to the 23rd atom of carbon. And that's the answer for letter A. Letter A. Now, for B, they want to know how many oxygen atoms are present. And I'm going to do the same. The same because I want you to see the setting up of the conversion factor. But if you analyze the setting up of the conversion factor, you're going to realize that since for every mole of carbon dioxide you have 2 of oxygen, the amount of oxygen atoms is twice the amount of carbon atoms. Okay? So if you make that analysis, you will realize that. Okay? So this is the answer over here, but you have to express that with the correct amount of significant figures. Just remember that if you're going to use all the conversion factors, see, you have to use dimensional analysis to get rid of the unit of measurements that you don't want, until you get, see, to the unit of measurements that you want at the end. Super important working with the power of 10. I was moving the decimal point one place to the left, so I have to add 1 to my exponent in my power of 10, and this is the final answer for letter B. Now, for the last one, it says over here, what is the mass? What is the mass in grams of one molecule? One molecule. Okay. And I didn't start with the one molecule. I start with 1 mole. Why? Because I know that in 1 mole, I have this amount of molecules. Okay? Now, what is the mass of all these molecules? Molar mass, because you have this amount of molecules in 1 mole. See? Okay, I want grams because they're looking for the mass of 1 molecule. So at the end, I need gram per molecule. How I'm going to do that? Using the dimensional analysis. 1 mole of carbon dioxide has this amount of molecules. But 1 mole of carbon dioxide, because I don't want moles, has this amount of grams. And when I'm doing this dimensional analysis, I'm making sure that on the top of my numerator, I have grams. Okay, so if I leave my answer like this with the numbers, see, in 44 or around 44 grams, I have 6.02 times 10 to the 23rd molecules. And I don't know if you learned that in mathematics or in math, but this is a rate because you have two quantities that you are comparing with different unit of measurements. One is given in grams, one is given in molecules, but I want the unit rate. What is the difference between the rate and the unit rate? That in the unit rate you have the amount, in this case, the amount of grams for 1 molecule. 1 molecule. How are you gonna find the unit rate? Dividing by the denominator. And that's what I did over here. And you can make that analysis too. If around 44 grams, okay, if 6.02 times 10 to the power of 23rd molecules has a mass equal to 44, 1 molecule, what is the mass of that? That's a proportion. So you need to divide by your denominator to find the unit rate, and you will have that. It's not complicated. It's not complicated. It's like, for example, if you are buying a dozen of eggs, See, you are paying, I don't know, I'm making this up, 1.99 by a dozen eggs. Okay, how much are you paying for one egg? You know, this is a rate because you're comparing dollars and eggs. See, comparing to quantity with a different unit of measurement. But if you want to know the unit rate for the egg is how much you are paying for one egg. How do you go from rate to unit rate? You divide by the denominator. That's what I was doing over here. After having the rate per mole, because you know that I have this amount of molecules and per mole, and that I have this amount of gram per mole because this is the molar mass, I just have to find over there the unit rate. Okay?